Hello everyone, welcome back to FX021. In this chapter, I'm gonna teach you how to make green simulation in Houdini. So the first video we already have the monster and the ground prepared. So now we're gonna make our green simulation. So we create a geo folder called sand, and let's dive inside. So I have the object merge for the ground. So we bring the ground here, and we also have an object merge for our monster. Okay, and I have an attribute transfer here. You can see the one here is black. So I don't want to turn all the grid into a sand simulation because it's gonna take a lot of memory and usually requires a lot of simulation times. So I only need to simulate these black areas. Okay, you can see if we template our monster here, you can see this area is where the monster gonna collide with. So we don't need to waste our simulation time on the one that it's not gonna collide with. Okay, so for the monster here, you know it has animations, but we just use a time shift now. I time shift it at frame 290 here. So you know, I think by default it's here is using the expression called $f, which I just delete that and change it to 290. So now when you scrub the timeline, the monster doesn't move. And I unpack it. I think I already unpacked it, so we can just delete this node. And I just assign a black color. And for the ground here, I just give it a white color here. You can see it's a white, and our monster is black. And I use attribute transfer to transfer the CD attribute. You can see here I checked on the point here and transfer the CD attribute. And under the condition tab here, I just changed the distance threshold here. You know, the larger the threshold, the more area gonna turn black. So I changed it to 0.82 here. So, and after I get these black areas, I use the plus node to delete the white area. So just use scd.r equals 0 and change the group type to point and check delete non-selected. So all the white area will be deleted. And we only left with the one that the monster gonna collide. You can see it by template the monster, and if we play it, you know, you can see this is the area that monster gonna collide with. And we can turn off the template here. And I don't want to see the black color after we done the attribute transfer, so I just use the attribute delete here, and I delete all the attribute using a star symbol here. So now we don't have the color on it. And after that, I have a peak node here. So you can see peak node like move the grid up a little bit because I want to turn this geo to a green source, so it will have our sand on this geo, but this geo is extracted from our landscape, so our green source will be exactly on the landscape. I think it will cause some collision problems, so I just use peak node to move it up a little bit, like 0.03, so our sand source will not collide with our terrain at the first frame. So I think it will not have any collision problem at the first frame. So I just move up a little bit, and when I simulate it, I will delete, like I will render at frame 24. So the frame 1 and frame 24 will let my sand have some gravity and fall down and let it rest for a while. And yeah, so our simulation will start at 24. So I just use a pick node to move this geo up a little bit. And this node is I can find the edge of it, which I will talk about later. And yeah, I just use a poly extrude to extrude this geo a little bit, and I use and you can check output back when you extrude. And then I use a smooth here. You can change the strength here, so the mesh is a little bit smooth, so the edge is more natural. So yeah, then I use a Vellum Constraint Grid to turn that into sand. So you need to be careful with the particle size here. So when you test out your simulation, you might need to set to 0.02 or like you want to have less particle size, okay? Otherwise it's gonna be heavy, okay? So you can also turn off display as spheres, so it will be, I think it will be faster. And you can turn on jitter scale, okay? So the result will be more random for your source. So let's put our view flag on the Vellum Constraint Grid. Yeah, now you can see this is our sand, okay? Because I use a pick node here, so when we simulate and it has gravity, it will fall down and collide with our terrain. Otherwise, if we don't have the pick node, these will be some of these, because I extrude them, so some of the grain might be under the terrain, and I think it will have some collision problems. So I use the pick node here. And yeah, so the Vellum Grid, it will generate the constraint and the grain for us. So yeah, just use my settings here. And now I'm gonna talk about the bound here, okay? So I use a group node here to find the edge here. So you can turn off the uncheck the base group and change the group type to edges, and include edges enable, and check unshared edges. So the unshared edge will be these bounds here, and you can name it bound, so you can reference to it later. So these orange lines are our bound group. Why we need this, I will show you. So we will, for our green simulation, we will have a mass attribute. You can copy my code here. It will set our mass from 0.1, between 0.1 to 0.3. You can check the geometry spreadsheet here. You can see the greatest is 0.3, the lowest is 0.1, and there are some value in between here. And if we put our view flag on it and visualize our mass, you can see these blue-white dot here. So they kind have the same mass. And the problem I noticed that is when I simulate these grains and let it fall down onto my terrain, they will slide. So the outer ones will slide forever. So what I do is I increase the mass of the sand on the bound here, so these particles will not slide. So when they fall onto the terrain, these particles will not move too much. So the technique I use here is very similar to the one here, using an attribute transfer. You can see here when I got this geo here, I turned that into a green. But here, because we create our bound group, I can delete the center area and left only the bounds here. You can change the group type to edge here. So now this geometry is the edge here. And I use an attribute transfer here. So the mass here, I just give it to phi. And this here, the mass is 0.1 to 0.3. So now we have these edge areas. We just use another attribute transfer here. Just transfer the mass attribute we create here. Okay, so we transfer the mass that equals phi to the green here. Okay, so now you can see after we attribute transfer this mass here, you can see this is the visualization of our mass on the green source. You can see the edges here. They have more whitish value, which means they have greater mass. So now that when these sand fall down onto the ground, these part will not move that easily. Okay. So now that we have our mass attribute set, and we can turn off the visualization on the mass here. And you notice that I also have attraction weight attribute here in the attribute warp. So let's dive inside. Let's put our view flag on it. And what it does is the attraction weight attribute here, you see here the simulation here, you see there are some chunks of the sand and some are like small sand here. So it's the wet and dry sand. So if you want some variation of the sand, like the size here, you see this is some big chunk. These are like small chunks here. So the attraction weight are for the wet and dry sand. So you can set the attribute in the source and it will recognize, Houdini will recognize this attribute in the top network and simulate it. So I can, for better visualization, I can plug that into CD attribute here so you can see it. So you can see this is the black and white areas. So some areas will the sand will be more wet and some will be more dry here. That's what you see here when the monster come out. You know, you can see these part are like smaller, and these part there are some chunks here, you know. So this is done by using the attribute attraction weight here. So it's the same thing here, just use the turbulence noise and add that to the position, but we can plug that into CD here. Okay, but you'll notice that you can see, hover your mouse on the thumb here, you can see here it's a vector, so you know they have RGB value. So I just turned that into a black and white value here. So because it's a vector, so I use a vector to float node here, and it just use, so it will have the RGB value. So I just take the green value here, and I use feed range here. So the source here is -1 and the max is 1. So I change it to 0 to 1 value here, and now you can see before it's something like this, and after I feed the range here, it's from 0 to 1 here. So this is for visualization, but we don't need color on them. So I just use a bind here, so you can export the attribute here. So the name is attraction weight. So you need to be, the name need to be exactly the same, so the Houdini will recognize this. So it's extraction weight and the type is float. And yeah, you can copy the setting here, and you can disable this because it's just visualization. And now we have a traction weight attribute here. You can visualize here. Yeah, it should be the same in the viewport. Yeah, now we have our mass set and we have our attraction weight set. We can dive into the top network, and yeah, these parts are the green here, so these parts are for the green. And when we use Vellum constraints, it generates the constraint for us. So you just create a null here for the constraint and create a top network and put the constraint under the input, the second input, and green to the first input here. Okay, and let's dive inside into the top network. So inside top network, the basic thing you need to run the simulation is you need to have a Vellum solver, Vellum source, Vellum object, and gravity here. Okay, so you can ignore all these extra stuff like this. You don't need this. And yeah, these are the nodes you need to run a basic Vellum simulation. So in the Vellum source, you can, the sub path here is the object sand green, which is, I just copy this and paste it there. And constraint, I just copy this and paste here. And I think that's it for it. And Vellum object, I think I haven't changed anything here. It's it's a default thing. And you can add your gravity here. And the Vellum solver here, I think I tweaked some settings here. So if you run the default simulation here, you'll find the green source move quite jittery. It's because we have only one sub-steps. So you can increase to 10 or 20 sub-steps, depends on your PC. So I use 10 sub-steps, so it will calm it down. It will not move so quickly. And also we have our mass attribute here, so that it will be not very jittery when we simulate. Okay, so first thing, you need to have a high sub-steps for green simulation. And I think everything else are default here. And now we can go to the advanced tab here. And you can see the default mass here. If you hover your mouse here, if no mass attribute is on the incoming geometry, this will be used as the default value for points. But we already, have our mass set in the sub level, so we don't need to mess around with the value in the tops. And here for the motion here, max acceleration, I just turn down a little bit to the 25. You can tweak the settings because different situations the settings are different. You can play around the value here. And also the sleeping here, if you turn on it, then the particle will be set to stop if it's remain near stationary for some time. But we can't turn it on in our case, because if I go to our send cache here, we set it, because we use the peak node here, so the sand here is above our terrain, and it will simulate it because we have gravity, you can see. So now at the frame 24 here, it's set on the terrain, but our monster here are still under the ground. But now, because it's already passed, so from frame 14 here and to frame 24, these particles kind of stay on the ground, and they already be on the ground for some seconds here. So if we turn on the auto sleep in the dop network, then all these particles will have a stop attribute set to 1, and then if we our monster go above the ground, and these particles will not collide with them because the attribute are set to 1 here. The stop attribute are set to 1, so we can't turn that on. But in some other cases, you can turn that on. So let's go back here, stop simulation, go to the first frame, and in the green collisions, I think I turn on ignore neighbors in same piece, and you can play around with the attraction weight here. I think because we already have the attraction weight in the stop level, so I think the value will multiply with the 0.25 in the dop network here. So yeah, and you can play with attraction and shock scaling power. So it's basically the amount of scaling to perform on these screens. So I think that's all I change in the Vellum solver. So basically the input thing is the mass and the attraction weight, but we already set all these in the stop level. Okay, and now that these are the collider, we can turn that on. You can see we have the collider here, and so for collider here, you can create a static object, and the stop path here is the one we create in the here. So the stop path is the one here. It's the polygon. Okay, and we can copy it and paste that into the stop path. And let's go back to the dop network. And we also, you need to go to the collision here, change the mode to volume sample, and under the proxy volume, use the VDB collision on the right. So it's the one here. So do that for both ground and the monster. Then you will have the both colliders, and just merge them together and merge it with the Vellum solver here. Make sure these are on the left and the Vellum solver are on the right, because the collision relationship is set to left inputs affect right inputs. So or if you don't want change the order, you can just set to mutual here, then it doesn't matter. And yeah, and also add some pop drag and pop wind here. So the drag here, I add some wind velocity, because you can see the sand can have some wind force to affect them. So I add the x-axis, so the wind will go this way. Okay, and I add some air resistance here, so the particle will slow down a little bit. And I also add some pop wind, add some amplitude here to make some noise on the particles. So for the amplitude here, so the amplitude parameter is AMP if you hover your mouse on the amplitude. So I just use a random value for each point and feed that value to from 0.1 to 0.35 to 0.35 to 0.85. Okay, so that they will have a different amplitude, and you can play around with the swirly size here. So I think that's all I did for the green simulation here. And then when you export the Vellum sim here, you can write the expression here. Otherwise, it will also export the monster collider and the ground geo here. So just type Vellum here and just put down a file cache node here and cache all the frames. Now that we have, if you cache your simulation, now that we have our simulation here, so you notice that I have another attribute Bob here. So you can disable this. This is just for you to visualize, but I export as a bias here, and I use this in the when I render the sand, because I don't want my sand to only have one color. So I use two colors to blend between these sand. So this is noise I use. You can use turbulence noise as well. But for you visualize, so the white here will be one color and the black here will be another color. So if you go to the stage here, loop network, and go to the sand material. You can see here I import the attribute I create in the sub there. I use a bias attribute here. Using I use a color mix node to mix between these two colors. Use the bias I create in the sub before, and plug that into the base color so that my sand will have a mixed color between these two. Okay, and yeah, that's what I did for this one. So you just create a noise here and export the attribute. So it's a float and called bias. And also the sand, you can create a p-skew here. The p-skew is the when you render it, it's how large is your each point. So you can create random here and feed that into 0.006 and 0.008. Depends on how many simulation, how many particles you have. So if you can see here, you can see the sphere sand here, because the simulation I do is not very detailed, so you can see the sphere shape here. So if you have more particles and smaller p-scale, it will be more like a sand. Okay. So I just use null here to output the sand. So you can see in the viewport, these also affected by the p-skew. So if we disable the p-skew, all the sphere will be the same size. And now that we have our p-skew, you can see they can have different size here. So yeah, and yeah, that's it for today.